Hello, this is Paul from Foresight Tech. In this lecture, we are going to go over logarithmic functions. Okay, and the major one, we're going to look at the rules of a logarithm. Okay, so first the definition for log is the inverse function of an exponential function, right? So from the exponential function, you will learn the basic graph of log. So that one we will not go over. We just go over this rule. We'll look at the basic rule. So the basic rule is these two. So log A is the base, right? Log A at 1 equals 0. Okay, log A at A is 1. Okay, and the inverse rule. Can you see the first inverse rule is what? This is a composite function, right? So the log composite composed with log composed with exponential, and that goes back to identity function, right? Okay, because what? Because both of them is a inverse function. So composed together, of course, you get identity function. See, if the base are the same, so you cancel everything, get x. And this is the same. Okay, it's exponential function composed with a log function, composed with its inverse function. So there A is the base of exponential. A is another base, is there the base of a log function, the same base. So cancel everything, we get x. So this inverse rule is important. Okay. We have a product rule, and we take a log to the product, we change it to the addition. Okay, can you see? Change it to addition. A normal error is this. So probably someone will say, do you think this is correct? Somebody probably say log. Wait. Somebody will write A is the base, xy equals log x times log ay. Okay, do you think it is correct? No, this is wrong. Keep in mind that it's easy to make this type of error. So where is wrong? Here is wrong. Should be plus. Should be plus. And then we look at the second is a quotient rule. Okay, take a log to a quotient goes to subtraction. Okay, another easy mistake is this. Someone probably will do this. Okay, we'll get it longer a little. Here you see. So another easy mistake is log of the quotient equals the quotient of log. Do you think this is correct? No, this is wrong. Okay, this is wrong. Should be what? This should be equals the subtraction. Okay, the difference between log ax and log ay. This is correct. That's wrong. Okay. And let's go over another power rule. So if we have a power here, take a log, and the log can simplify. Okay, so log can simplify the power. Can you see? We don't have a power, right? The power usually we say is laid down. It goes to the power times the simple log. The last one here is change of base. If we have a log, so can we change it to the base from A, change it to the base from B, to B, from A to B is this. This is a formula. Okay, it's log bx, log ba. Okay, and if we take a b as 10, this we call the common log, right? Common logarithm. And if we take a b equals a natural number, okay, all our number e goes to a or n, natural logarithm. Okay, both the common and the natural logarithm you can find in your calculator, right? So Texas Instrument. This is the basic. Let me go over some questions. Okay, so how to use this the basic rules, and use the rule to rewrite and simplify. And why we need a log function? Because log can help us to simplify something. Okay, for example, if we have this, okay, we can get a symbol. Okay, for this, how do you can imagine what the function, what the formula do we have? We have a lot of rules, right? But first, we don't see direct rule to help us simplify. But we learned another rule, basic rule from what? From exponential functions, exponential rules. So 1 over e raised to the second power, we can write in negative power, right? We call it negative exponent. First, ln is what? You know, ln is natural logarithm. The base is e, okay? So let me see. Whatever the first step, we can use a negative exponent. If we say the original is this, ln 1 over e squared, okay, we can see is ln at e raised to the negative 2's power, right? So this we call the negative exponent. You can say negative exponent. Okay, we just use this. So now look is better, but which formula we can use to simplify? Keep in mind, so ln is the base. If we wrote it this way in this, ln is loge, okay, right? And then e negative 2. You just imagine, okay, a is the same base, right? The base are the same. The inverse rule tells us cancel everything. We get what? We get a negative 2. Okay, we get a negative 2. Okay, so I directly get it. The answer should be negative 2. Which rule we used? We use the inverse rule. Inverse rule. Okay, so that's the log composed with the exponential. Okay, so we get the identity function, which is a negative 2. This is 1. I'll look at another here. And look is good. The look at this. Look is good. We have this another inverse rule. Can we see? If we see e ln 5, we have another inverse rule is a log a x equals x, right? Okay. If we have this, so it's easily to use the inverse rule to get it, simplify everything. However, we have 2. So how to deal with these 2? Do you remember the power rule? These 2 we can take back to the power, right? Okay, we do have a power rule. Do you remember what the power rule? If I write it here is ln 5 square. Take a parenthesis. Do you remember this equals how many? Equals 2 times ln at 5, right? That means the power rule tells us the power take down is 2 times ln 5. Can you see? 2 ln 5, we can take 2 back to the power, goes to 5 square. Okay, just use that. And then you will see what the answer. Okay, so can we see the original? So e raised to the 2 times ln at 5. So we just say take 2 back to the power, which means e ln parenthesis 5 square. Okay, now we can use the inverse rule, right? This is the power rule. So we can see this should be the power rule. We say this is the power rule we used. And then is e the base. Here is another base e. The same base, we can cancel everything, right? Inverse rule. We can use inverse rule. So after we use the inverse rule, we get a 5 square, right? So this is x. Or we say this is a inverse rule. Okay. And now you have 5 square is 25, of course. This is the answer. Not difficult to use the basic rule. Let me look at one more example here. And this time is another little bit complicated, but when we go to the end, you will see the answer is so simple. Okay, this you can imagine if we have a very complicated functions like this, square root of what, and the logarithmic function is very important for us to simplify this type of expression. Okay, how to simplify? Let me go into step by step. So the first, which root help us to simplify? Okay, if you check back, okay, this is Lucas quotient, but we cannot use quotient. Why? Because we have a square root there. We need to deal with the square root first. Do you remember how to deal with the square root? That's power. That's 1/2 power, right? Okay, so the first, we change it into exponent. So how do you say? Let me copy this first. This is ln, the original. Okay, this is a big one. This is x with the 5th power, y the 2nd power, z the 7th power. Okay, so we're going to get what? We're going to get the square root out, which means a power of 1/2. So how to write? So I have to get like this big one. Okay, and the middle one raised to the 1/2 power. Okay, so here is a complicated expression. Is this correct? This is simply we call the change to exponent, right? I just change it to exponent. Square root is 1/2 of the exponent, and then what do we do? Okay, so this is the power, right? This is a ln goes to a power expression. Okay, so the power, we have a power root, the power can lay down, so that's very important. So now let me copy to here. So after I copy, what do we get? We should get like this. So after the copy, so what we get, this is 1/2 lay down, right? So 1/2 lay down is this 1/2 times ln, and then parenthesis x with 5th power, y 2nd power, over z to the 7th power. Can you see? This is all we use. This is the power rule. Okay, so this is what? This is the power rule. So now good. So we're good to go. Let me put here. So what did we use? We use the power rule, right? We use okay, but here is like a power rule. It's okay. Now it's easy. Why? Because we see a quotient. Keep in mind that, and the ln, take ln to the quotient is goes to subtraction, right? So we just see. Okay. So don't make a mistake. It's not a quotient again. It goes to the subtraction. So what do we have? We will have this. We will have 1/2 go to subtraction. Don't miss this big parenthesis. ln, the numerator, I put a parenthesis again, minus ln at z raised to the 7th power. Okay, so this is which rule? This is quotient rule. Okay, this is quotient rule. Okay, always say it's a quotient rule. Okay, now what do we do? So we deal with this, and this is a one part, two part. Okay, so we simply say this is a part, this is another part, this is a product, right? This is a product. Take ln to a product, we change it to addition. Okay, product rule. So now you know we have like okay, I'll put it here first. We use a product rule. See, what do we get? We will get a little bit longer. We get a 1/2. Product goes to addition. The first is 5th. The second is y squared, right? Product goes to addition. That's a product rule. Okay. And then now what do we have? Okay, so it's the minus ln z raised to the 7th power, parenthesis. Okay, the last one is power rule, right? take ln to a power, the power laid down, the power laid down, the power laid down. So this is the final. Can we see? This is 1/2. Okay, is 5 is the power laid down ln x. The power laid down, take the power down is ln y. Take the power down is 7 times ln at z. What's the rule we use? The power, right? This is a power rule. Okay, so that's all for these questions. Okay, so can we imagine what the beginning? Can you see a little? The beginning is complicated. This when we take ln to this complicated expression, we look at the final. Okay, it's just a linear combination of a basic ln function. Okay, this type of simplification is very important. Very important that when we're going to implicit differentiation. Okay, I mean that if we have a complicated functions, we want to take a derivative. How to find derivative? That's complicated. Take ln first, simplify first, then going to take a derivative will be very easy. Thank you. That's all.